Let us look at proposition number 12 of works of Archimedes, specifically from on conoids and spheroids. So let's begin a little bit of it and then I'll tell you what the proposition is talking of. We are given a paraboloid. Let it be cut by a plane neither parallel nor perpendicular to the axis. So it has to be at an angle. So this is called the cutting plane. Let a plane through the axis cut the paraboloid perpendicular to the above plane. So we have to draw a plane which is perpendicular to this plane. So let's first draw the axis and now let's draw the plane perpendicular to this plane. Now these two planes will cut in a straight line. Let's mark it as R, R prime. Above planes intersect each other in a straight line R, R prime. Draw RH parallel to the axis. So let's draw RH parallel to the axis. From R prime, we draw a perpendicular to RH, which will be R prime H. So basically it will be a straight line, this will be a straight line, and H will be an intersection of these two. So R prime H is perpendicular to RH. Now let Q be any point on the section of the cutting plane. So the intersection of the cutting plane with the paraboloid. Let's mark that. And now we have to take a point Q on this section. What the proposition is saying, I'll take the Q now. What the proposition is saying is that this is an ellipse whose major axis is R prime and the minor axis is equal to R prime H. So basically we have construction part is done as far as arriving at the minor axis of this ellipse. But now we have to prove. So for proof, we continue with our construction. So from Q, we drop a perpendicular to R prime and let's mark it as M. So QM is perpendicular to R prime. Now through M, draw a line DE perpendicular to the axis. DE, this is perpendicular to the axis. And let's mark the intersection of the axis and DE be F. Draw a plane through DE and QM. So DE, QM. Let's draw a plane through those two lines. And the intersection of this plane with the paraboloid would be a circle. So immediately you notice that we have a straight line DE on which we have a semicircle and we have a point Q on the semicircle and a perpendicular drops to DE, which means what? Which means the plane DEQM intersects with the paraboloid in a circle. That's fine. It means that DM times ME is equal to QM square. Now, let PT be a tangent to the parabola. Which parabola? Let's draw the parabola, which is the generator of this paraboloid through R prime. So this is our parabola. We have to take a tangent PT, which is parallel to R prime. So let's take a tangent which is parallel to R prime. Let it intersect with the axis at D. Now, AO be the tangent to the parabola at A, intersecting with PT at O. So we have another tangent at A, intersecting PT at O. And next, we draw PN perpendicular to the axis. Now let's hide off these tangents. So here you will notice that PN is perpendicular to the axis, OA is perpendicular to the axis because it is a tangent. So which means DM times ME is to RM times MR prime is equal to AO square is to OP square. This is from proposition 3, first part. DM times ME is to RM times MR prime is equal to AO square is to OT square. How did this come? OT instead of OP. Because triangle AOT is similar to NPT. Basically, OA is cutting the opposite sides in proportion. So here OP is equal to OT because NA is equal to AT. So QM square, because DM times ME is QM square. QM square is to RM times MR prime is equal to AO square is to OT square. Or we can say QM square is to RM times MR prime is equal to R prime H square is to R prime square. Because triangle AOT is similar to RHR prime. So because of their similarity, the ratios are same. What this tells us is that QM, the square on QM is to RM times MR prime is equal to R prime H square is to RR prime square, which means Q lies on an ellipse whose major axis is RR prime and minor axis is equal to R prime H. Beautiful, right? That was proposition number 12 of works of Archimedes, specifically from on conoids and spheroids. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.